With that, today we have two great speakers from Atlantis. We have Patrick Brennan, who's Senior Product Manager of Applications and Platforms, as well as Jim Moyle, who is an Infrastructure Technologist and CTP. With that, I will turn it over to Patrick to get started.
Thanks, Michelle. Let's take a look at the agenda that we'll be discussing today for the webinar. So we'll lead off with just talking about challenges that face IT organizations today regarding databases and just overall storage challenges that IT organizations are facing. And then we'll talk about how Atlantis USX is significantly reducing costs, transforming and consolidating your data center, but also significantly reducing the overall storage costs of your infrastructure. And then the star of the show today will be Jim, who will be talking more about Microsoft SQL Architecture with Atlantis USX, how you can fully take advantage of Microsoft SQL's in-memory OLTP whenever you complement it with the Atlantis USX solution, and he'll dive into the details and the architecture centered around that. And then he'll show you the exciting results we have regarding the IOPS testing, the HammerDB and SQL IO benchmarks results that we got that really show you how Atlantis USX is changing the game whenever it talks about when you're talking about Microsoft SQL databases and the acceleration and performance that we're giving those databases and how that translates into cost savings and other byproducts of that conversation, right? So that being said, let's just dive right in. So I think there's no, oops, let me go back one there. Sorry about that. There we go. So I think there's no secret here for the audience that's here today that the data is growing exponentially, and demand for it is as well. So here's some interesting data points that you guys may or may not have known. So every 60 seconds, you're looking at approximately, at least estimated out there, is 1,820 terabytes of data being created, tons and tons of Google searches, 2.5 million pieces of content posted on Facebook. So a lot of baby pictures and cat videos are being posted every 60 seconds for sure. So IDC basically says that by 2020 there'll be about 22 million petabytes of information out there, which is about 10 times the amount of data that's out there today. So if you could just imagine an IT infrastructure having to support 10 times the amount of data that's currently in your data center, doing things the way we've been doing them the past 10, 15, 20, 30 years is just not something that's totally sustainable as this transformation in data is occurring. So as we look as what's also driving some of those changes, enterprises are being leveraged to use more powerful applications that provide greater detail and insight into the business, right? So now before it was very simple, right? Accounts receivable, accounts payable, and that's pretty much the net of what we could do in terms of overall financial type transactions, et cetera. But now we can take all kinds of other data and metrics that we never took before and spit out all kinds of information that help us make more interesting business decisions and more agile business decisions that kind of could potentially change the way that we do our business. Allows us to maybe divest from certain areas and invest more in other areas where we're being more successful, based on these types of systems that are being deployed and databases that are being used as a result of that. And big data is also changing the game as well. So there's an organization out there, NASCAR, I'm not sure if you guys have heard of them, big organization, makes a lot of left turns. And there's something interesting I was reading about them not too long ago where they started collecting Twitter information, which by itself you may think, well, Twitter information, that's not necessarily all that interesting as it relates to a business perspective. But what they started doing was they would collect the Twitter information and posts and tweets and everything else, and then started correlating that data to what they were covering at that given time. So you could see that, oh, maybe they like this particular segment or that particular segment, and started correlating that data to seeing, what's successful when we do certain things one way versus another. So, that's all about what big data is, right? It's taking that information, storing it in a database so that you can analyze it, provide some analytics to see, okay, well, inherently these two things by themselves don't really tell us that much information, but when you combine them together, suddenly you've got a lot more insight into, what's working and what's not, and that's also really helped driving this conversation of data growth and databases, et cetera. So when you look at what that translates into to try to support all that, right, astronomically expensive and only getting worse. So according to Gartner, you're looking at somewhere around 326 billion in storage spending in 2019, and if you probably threw 2020 in here, you're looking at about $500 billion in terms of storage spending, which is almost comical to talk about. It's just so much spend and just trying to maintain and collect all this information and data. And if we continue down this rate of doing things the old way, it's just not sustainable and doesn't make a whole lot of sense, right? And that's where Atlantis USX comes into play. So Atlantis USX is one of our products that allows you to, it's a software-defined storage solution that enables you to adopt the hyper-converged type architecture using any server or any storage that's out there. So you could take existing servers, existing storage that you have, whether it's spindles, flash, SSD, continue to use the SAN that you have for however much long shelf life it's got, and we could take a server, lay down a hypervisor, and put our USX platform on top, and instantly start taking the data storage that you have available and start consuming that and optimizing that as well. So when you look at it, this type of architecture, and compare it to the way we've been doing things before, it's like, why was storage ever a hardware solution? It should have always been a software solution, and hindsight's 2020, of course. But when you look at the value and the benefits of using a software-defined storage solution, it completely changes the game in terms of what you're able to do with that data and how you're able to manipulate it and increase performance as a result of that. So that being said, when we look at some of the value in this, right? If I was to take and deploy, Atlantis USX in my data center, for example, instead of using the traditional old clunky type of storage with big filer heads and proprietary shelves, I now enable my data center to be much more agile because I can just lay down the USX platform on any server or any storage that's out there and provide immediate storage to my environment using more commodity type servers and equipment and hardware that's available, and no longer have to have these huge giant maintenance contracts for these huge giant storage systems that I'm used to. And we can provide all the resiliency and everything else that's associated with that you get with those big systems as well, using software to do that for us. And as a result of that, it allows you to scale much more quickly because now you could take, again, any type of hardware that you have either laying around and repurpose it, or maybe even get some more resources out of it, or take more commodity-style hardware out there and scale immediately instead of having to go back to your storage vendor and say, I need this clunky shelf and put it into my environment and scale that up. It's just very, very proprietary, and so therefore it's not really necessarily as scalable as using a software-defined solution instead. Now, inherently, as part of moving towards a software-defined storage solution with Atlantis USX, we have a feature called Hyperdupe, which inside USX, which essentially accelerates, deduplicates a lot of that information, allowing you to get a lot more IOPS and throughput into your system that you didn't before. So when you're talking about databases, it makes a significant difference as transactions per minute are everything. And we'll talk about that more in detail, and Jim will share the results of how we're accelerating those type of workloads and how we're providing value to that. And inherently with that as well, because we're now taking those storage bits and inspecting them, we can also provide additional capacity to the environment as well, because on average we're seeing somewhere between 70 to 80% reduction in required storage capacity because of the fact that we're able to deduplicate that data and just store only the delta bits as time goes on over time in your environment, which inherently is a cost savings option, right? So because I'm storing less, because I'm using more commodity style hardware, or at least not necessarily investing in these huge storage solutions, I can save significantly in my environment by switching this type of solution. And Jim, of course, will also be able to talk more through that as well. So another product we have available also is our Atlantis Hyperscale solution. So Hyperscale is essentially an appliance that you stick into your existing environment, and it's a 2U box that has 4 nodes, and it's an all-flash array. So it has SSDs inside. It's extremely inexpensive, and we have a lot of different storage a lot of different server options available for you. So we have an appliance for Cisco, HP, Lenovo, Supermicro, and you choose which one you feel comfortable with. So we're agnostic in terms of how which hardware vendor we use, but it doesn't matter. We'll be able to accelerate and provide those same value options that I was talking about earlier into using this modular type of architecture. So once you take all your VMs and put it on this infrastructure, and you see the results and the performance and capacity savings that you're getting, you can easily just slide in more and more boxes and scale your environment accordingly. So there's a lot of different ways to deploy Atlantis, and underneath the covers are hyperscale boxes using the USX architecture. So if you want to roll your own storage with USX or use your own hardware, that's fine. But if you want something that's more modular and easily predictable and scalable, we have this option available for you as well. So as it relates specifically to databases, when we look at the data that Jim's going to be sharing, we came out to about as low as 18 cents per transaction per minute when we were doing some of our testing. So when you compare that to what else is out there, I was looking at tspc.org, which is a good resource for other vendors and other solutions that are out there. I was looking at most solutions out there were in the 50-cent range plus. So we're significantly less expensive because of the value add of what we're able to bring to the table for these workloads with acceleration, deduplication, etc. Now, when you're talking about SQL, one of the main things that drives into cost of these solutions is the per server licensing from Microsoft, right? So if I'm able to provide more transactions per minute for a single server to a single server, I'm able to reduce the amount of servers that I actually need to provide the same level of transactions per minute that I did before. And as a result of that, you're going to lower your SQL licensing costs because you're not going to need as many servers to provide the same level of throughput and performance that you had before, which inherently also lowers your hardware costs as well because you're not having to spend all this money on additional hardware, support, storage, and everything else as a result of that. So as a raw performance perspective, and this is all high level, and Jim will talk about the actual details of this, but you're looking at 5x more transactions per minute whenever you're using the USX platform. Now, that's all well and good, but what does that really mean? The benefit, I think, when I look at this and take away from the performance aspect of what we're bringing to Microsoft SQL is that, 80% less time in batch completion is a huge deal. So if I'm able to tell a business owner that, the transaction that took 3 days to generate or report on, now I can do in less than half a day, that's a huge savings because I'm able to provide that value immediately to the business and let them know, hey, I can get answers faster to you, so that you can make those important business decisions and get back to you quickly. So from that perspective, that makes everybody around, the IT organization, as well as the business owners, very, very happy. And it also equates to a better user experience. I mean, I've seen, databases out there where it's like they go to make a financial report or something along those lines, and it's like, well, let's let this report run back. We'll come back out to lunch because it's gonna take so long to get the data back that I need to process this information. So if we could deliver that and generate those reports and generate all that information in a much more timely fashion, it provides a much better user experience. It gets, again, going back to the business conversation of being able to have access to that information much more quickly. And inherently with SQL, we're also cutting capacity, as I mentioned before. So 70 to 80% in terms of less required capacity to deliver the same type of data and information that you are today. So that's a huge savings in terms of overall required amount of storage that you have, which inherently reduces your data center footprint. So you can repurpose servers, repurpose storage, or even just overall save space, cooling costs, and everything else as it relates to that, and inherently lower your risk because you're having less hardware to maintain, less opportunity for failures. You're inherently lowering your risk as a result. So that being said, with the high-level stuff, let's let Jim take over and kind of share with you some of the exciting details about how we got to these results and how we got this information. So Jim, I'll turn it over to you at this point.
Thanks very much, Patrick. Just a small point of clarification on what Patrick was saying in the intro there. The hyperscale box is a true hyper-converged block. So it is storage and compute in a single 2U, not an all-flash array. I'm sure you didn't mean to say that, Patrick, but just wanted to clarify that. So, how does USX work? We'll go through a little bit of an overview on the internals and how we do what we do, and then we'll move on to the results straight after that. So, for Atlantis USX, effectively what we can do is we can grab any storage that you like, so be that shared or local storage. And that local storage can be disk, it can even be RAM, or it can be SSD. We'll even do flash on DIMM as well, although the price for that is probably a bit high for people to consider just now. In the future, we will be able to bring cloud storage into that as well, solving some of the latency issues that occur around cloud storage. And what we do is we pull all of that storage together, and we have our own software as a layer of abstraction over the top of that. So you no longer care where that storage is coming from, and it becomes completely irrelevant to what you're presenting at the front end. So, data services. Data services layered on top of dumb storage. So, we already mentioned deduplication. So, deduplication is an interesting topic, at least to me anyway. And our deduplication is inline and built for performance. So you tend to find that a lot of deduplication solutions on the market are built for capacity reduction and not performance. Now we get obviously the capacity reduction as well, but the key bit here is inline deduplication with performance. We do have compression technologies in there as well. I/O acceleration, caching and coalescing. So caching for the reads, giving the right blocks up front. We've got some very clever algorithms to make sure that the right data is up front and easily accessible to the application. And coalescing if you're writing down to disks, increasing the block size. Provisioning, we have fast cloning, so you can clone any size of VM in about 8 to 10 seconds, and most of that is actually registering the VM with the hypervisor rather than the actual cloning itself. Customization as well during provisioning. Data mobility, teleport. Teleport's a very cool thing. So teleport, if you have a deduplication file system on one side and a deduplication file system on the other side, typically of a WAN link, then you know what blocks are on one side and what blocks are on the other side. And if you want to move a VM or move files between one location to another location, what we can do is we can intelligently optimize that job. And that means that if the blocks already exist on the secondary site, we don't move them. So effectively what we're doing is we're disassembling the VM on one side and reassembling it on the other side, hence calling it teleport. Replication and snapshots will be available in our next release, in the 3.0 release. We also have encryption and data protection if you are storing your data in somebody else's location or even on the cloud. High availability backup and DR, obviously a necessary thing when you've got a SAN-like solution or trying to provide SAN-like features from what we are doing here is any storage. If you were to present your application with storage that is designed for that application, so if you have a SQL workload or an Exchange workload or a desktop workload, generally you will purchase a bit of storage to go along with that workload, and then that is tied, and it's very difficult to flex that to scale out or scale up. Because everything is software in Atlantis USX, then we can vary the capacity, the performance, and the availability just in the GUI. So it means you can then pick what capacity you like, pick what performance you're getting, and pick the availability on a per volume basis. So giving you the ultimate flexibility to create whatever size and whatever availability of storage that you need. And we can do that over any protocol as well. Well, not any protocol, but we can do it over file or block, so NFS or iSCSI, depending on the needs for your environment. Just a quick note on hypervisors here. We'll support Zen Server, and vSphere for this product. Automation, massively important for large organizations where you've got tens of thousands of VMs and hundreds of thousands of users. Automation is key. You need to be able to design and eliminate in such a way to eliminate human error as much as possible. We build on our GUI on our own publicly documented REST API. We also have PowerShell to automate it. So if you are big on automation in your organization, we absolutely have the tools to enable that if you so desire. And through that, we can integrate with lots of third-party products. Obviously, vCenter. vVols is very interesting. So vVols come around with vSphere 6. And what vVols does is effectively surface up the characteristics of the underlying storage into vSphere. So you can then tag your VMs with the correct fingerprint of storage that those VMs need. And then you can make sure that nobody moves your workload to a piece of storage that is inappropriate. By being software and being able to layer on top of any storage, we can make any storage vVol compliant. Very, very interesting thing to be able to do to your existing storage and take advantage of citing new features within vSphere 6. So, broad overview of how we work. This particular configuration that we're going to be talking about for SQL and for the testing we did is basically local flash. Now, as Patrick mentioned earlier, we have our hyperscale hardware appliance. That is also this same configuration, which is hyper-converged across local SSD. So the dedupe means that we heavily optimize capacity, so you can buy smaller, cheaper SSDs underlying it. There's some extremely good options out now from the big server vendors, which, you know, fairly large SSDs with a reasonable write endurance, and the cost of those is coming down all the time. Local flash, so without any optimization on top of it, you're missing out on features like resiliency, HA and stuff. We will add those in via software when we're sitting on top of local storage. And failure to tolerate, you can either have 1 or 3. For failure to tolerate 1, you need a minimum 3. For failure to tolerate 3, you need minimum 6 hosts. So, what's the minimum requirements? Minimum requirements is 3 hosts. Minimum RAM, 72 to 92. Nobody really buys those servers of that size anymore, do they? I think 256 gig is minimum really for what people are buying now. One of the reasons we're so quick is we hold our dedupe metadata in RAM, effectively enabling that super quick deduplication of data as it's coming down. And as I said before, using local SSDs. One of the things you can do with those local SSDs, because we're providing the resilience on top, you can actually save a lot on local SSDs by doing RAID 0 instead of RAID 1 or RAID 5 on those local flash. Because there's no need to have that resiliency underneath if you already have it in the software layer on top. So, SQL Server. Now, it's quite a big topic, right? Because there's SQL servers and there's SQL servers. Now, from something that's just in test dev, you know, SQL Express, and it's just there to hold monitoring data, right up to tier 1 global multi-site environments for mission critical applications. So there's no one single SQL server out there. What we're mainly concentrating on is the larger, more enterprise characteristic workloads, rather than those sort of single server where you don't really need a lot of performance. You can just chuck it on whatever you like. Nice case study that we have. So, financial services database. We put our software in and we got essentially about a 5x performance improvement, both in transactions per minute and batch. And we achieved this without actually buying any additional hardware for the customer. So they used our Atlantis USX software, downloaded it, installed it, and got this on their existing hardware. So the cost benefits that they worked out, 5-year savings of about 1.5 million, and for each 60 terabytes of storage, and projected 5 years savings of over 10 million. So what did they look like before? Well, they look like fairly traditional converged architecture. So they had several hosts for vSphere, hosting SQL VMs and other workloads. And those were stored on a combination of Equilogic and Hitachi data systems. So I guess this is probably what a lot of people's environments look like now. And this is an architecture that I believe is going away. It's expensive, it's not agile enough, and it's not performant enough. So what we're going to do for this customer is effectively take those vSphere clusters, add our software to it. Now, USX software is just a bunch of virtual appliances. So there's no hardware to add to your servers. There is no drivers or VIBs to add into your hypervisor. Very, very clean, just NFS or iSCSI to communicate. So that means that it's really easy to integrate with existing systems, right? If you can use IP-based NFS software, you can use us. And we were deduping that workload onto their SAN and taking about 75% of the workload off their SAN. We observed almost a 5x increase in transactions per minute. Now, why transactions per minute essential to a SQL cluster? Because this is where your cost comes in, right? If you can lower the cost of a transaction, then you can lower the cost of your overall solution. Because you're paying your licenses to Microsoft, they don't care how many transactions per minute you can get out of that database. But if you can get more transactions out of a single database, it means that you don't have to pay for an additional license to host additional SQL servers. So this is why when you talk about databases, people are always going to know about the number of transactions. So increasing by 5x the number of transactions that people are seeing is a pretty good thing to be able to do. Quick look at ROI. You can read it yourself. So existing storage, putting us in front of the existing storage as a layer to accelerate them, and then once that storage has reached end of life, instead of buying any new storage, move them to hyper-converged. Move them to this local flash, given the performance of an all-flash array, but without the cost. And as you move across this table, you can see that you're saving more and more and more as you're changing the architectures. And bear in mind, you're still sweating your existing resources, right? This is pretty much the same data, but it's nicer to see in graphs. Anybody who's ever heard me speak before or seen me speak before knows I like a graph. We've got a few graphs coming, so that should be fun for everybody. Storage capacity footprint, 80% reduction, reducing costs, etc., right? So, what does our hardware look like that we're testing? We're testing IBM, obviously now Lenovo, 2 times 400 gig SSDs, and we had some spinning disk as well in those servers, but we weren't actually using that. We were just using the SSDs. Reasonable CPU and a reasonable amount of RAM as well. So what's it look like in terms of the logical architecture from the bottom to the top, right? You've got hosts with local SSD on the bottom. vSphere could be Xen server, but in this case it was vSphere on top of those hosts. And what we call our service layer. Now this is the first part of the Atlantis architecture. The service layer is essentially some virtual appliance, one of which sits on each host. And the function of those service virtual appliances is to make those local resources available over the network. So this is how we're aggregating all of those resources together. The volume layer is effectively a presentation layer. So it takes those local resources that we've made available over the network and then presents them in whatever way you want. As I said before, you can pick it in the GUI. I'll say I'll have a 3 terabyte volume at whatever performance, and I want N+1 on that, please. Oh, and I'll have it over NFS. And then the layer above, we see we've got a little change here, right? For standalone servers, i.e. ones that are not clustered, are not using the always-on stuff. I'll talk about always-on because we're talking mainly about SQL 2014. So if they're not clustered and you're relying on other ways to back up and restore your SQL server, or even if you're just relying on vSphere HA, we would recommend in this case that your database is probably NFS, and effectively you don't need to bother with the Windows clustering. If your SQL architecture is tier 1 and you're protecting it using application level resiliency, then you're going to need a combination of protocols really, because you need some block-based protocol because Windows clustering requires block-based protocol, so we can provide that over iSCSI, and then use NFS for data, transaction logs, etc., etc. And see then the databases layer on top. So one of the interesting things about SQL as a workload is this tendency, and it's Microsoft's best practice as well, to split these databases up, or the database workload up, into different constituent parts, right? So your transaction logs are in one place, your data's in somewhere else, and maybe even your temp DB is somewhere else entirely. If your database is especially large, people will even chunk your database up in different sections and put those on different bits of storage. Because we can pick what database, what data stores that we're providing and what performance characteristics they have, then you can effectively do an entire volume just for each of these chunks. And because the performance is on a per volume basis, so you'll get about 40,000 IOPS per volume. And say if you need 40,000 IOPS, you could stick it all on one volume. You wouldn't do that, not best practice. But if you wanted more than that, you could create multiple volumes and scale out your performance across. So it's no problem. If your database yesterday required 100,000 IOPS, but tomorrow requires 200,000 IOPS, you can create that extra performance in software without buying any additional hardware. The ability to scale out using USX, particularly in performance, is really interesting. What about resilience for this? So on the underlying service VM layer, you can have N+1 or N+3. And on the volume layer, for the volume virtual appliances, you can have end-to-end. So you can have as many HA volumes as you want, and as to in your HA cluster. Now, the HAs are internal HA, so it doesn't rely on the hypervisor's HA, which makes this platform independent in terms of capabilities, and it's also faster than the underlying hypervisor HA. So let's talk a little bit always on. So always on has a prerequisite for Windows clustering, so prerequisite for block storage, hence the iSCSI we were talking about before. Sync or async to multiple sites, and if you're looking at failover cluster instances, cluster shared volumes. Now again, fully support cluster shared volumes, so scale out file server on top of iSCSI drives. Very good way to do failover cluster instances. Here, this looks almost exactly the same. So we can effectively chunk up those SQL servers into logs, data, temp DB, and again, do iSCSI for the scale out file server underneath, and still with the same level of resilience. And you can pick the level of resilience, remember, underneath. Since we're talking about SQL 2014, and especially SQL performance, it would be very remiss of me not to mention in-memory OLTP. So in-memory OLTP is a very cool new feature within SQL 2014, and effectively holding tables in memory for fast access. Now, especially good for a more read-heavy SQL workload, because then if your reads are coming directly from RAM on the server rather than going down to disk for access. Now, due to the need, obviously, for SQL to be consistent, if you're writing to this in-memory table, what happens when you reboot? Are you losing those writes? Well, no, you're not. And the reason you're not losing the writes is because of the transaction log. And that transaction log is always on disk. So non-volatile storage for your transaction log. There's a very interesting Channel 9 video that I've got a link to on the slide, talking all about in-memory OLTP logging. And it almost mandates an infrastructure that has fast storage, even if you're using OLTP. Because if you're increasing, I might say, up to 20x transactions per minute by using OLTP, you need storage underneath your transaction log which can keep up. Otherwise, you're actually not going to see any of the benefits of OLTP at all. So it's almost unintuitive to think of it this way, but if you're going to turn on OLTP, you absolutely need really fast storage as well. So testing. And when I'm doing a lot of tests, particularly around storage, everybody talks about IOPS and throughput. What I really care about is latency. Yeah, how long you are having to wait, or the OS or the database is having to wait for a response back from underlying storage. Because we want to be consuming CPU. We want every single cycle of that CPU to be doing work, not waiting for a response from the underlying storage. So latency is more a function of the different layers and how many queues you have in between the different layers. Because wherever you have a layer, you have a queue to even out a resource supply and demand. So latency is the absolute key. Everybody knows Iometer. If you're thinking about storage and testing storage, very useful open source tool, can do simultaneous reads and writes. We're looking at this across a double volume, so simulating your logs and your data on 2 different volumes. And we're getting almost 80,000 IOPS. Now that's a lot of performance for a single database. Now you can put multiple databases on there and split up, or you could even just say, I just need that for all of my databases. And you can scale out again without adding hardware and just in software. Looks at the latency, average read response time, average write response time in milliseconds. 0.4 and 0.43. That is tiny. And it's this kind of latency. And remember, when you're doing the synthetic testing workload like you are with Iometer, this is designed to push your storage. This is designed to put it in a place where it can't cope anymore. So even when we're running at full chat, we're still servicing I/O at less than half a millisecond. And let's look at how that's split up across the different latency times. So we're starting off on the left here, 0 to 50 microseconds, and then we're getting to 1 to 2 milliseconds about halfway across. And we can see that in the 1 to 200 microsecond range, we're servicing 42% of all I/O in under 200 microseconds when we're being pushed. The rest of it, we're still serving at under 500 microseconds. And we can see that along the graph, there is no peaks. There's no other drop-offs, right? We're still serving pretty much everything under 0.5 microseconds, milliseconds. SQL I/O. Is SQL I/O a SQL testing tool? No. It is the worst named tool I've ever come across. It's basically just a Microsoft tool for chucking I/O at disk. Now, you configure it to look a little bit like SQL, but it's not. It doesn't even require a database there to run SQL I/O. So you tend to find that a lot of companies, and us included, particularly for, so you can compare and contrast between different vendors, will use SQL I/O for storage testing for SQL workloads just because the tool has got SQL in the name. It has no more relevance to SQL than that. So it's interesting that everybody uses it. Anyway, we're going to talk a little bit about block size here before we get onto the SQL I/O testing results, because block size is interesting in terms of what you're looking at. Now, there's a thought that everybody says that SQL I/O is 64K block size. It's not actually true, and you tend to find people formatting underlying disks at 64K because they think that all of SQL is 64K. It's only transaction log at 64K. The actual other peak for I/O in SQL is at 4K block size. So really, what you want to be looking at is performance. It's about 50% split between 4K and 64K. So those are the two different block sizes that you really need to be thinking about when you're looking at SQL testing results and SQL design. So we can have a look here, IOPS and throughput by block size. IOPS along the left-hand side, throughput along the right-hand side. Now, obviously, if you know your IOPS and you know your block size, you can work out throughput without even having to mention it. So, IOPS with SQL I/O. Now, SQL I/O can only do read or write, can't do a blended read and write workload. So this is a write workload. And we've got 120,000 IOPS and 2,000 megabits per second throughput. Obviously excellent. Now, what happens if we increase the block size? Now, I don't like 512K as a block size testing result for SQL because you don't see many block sizes at half a meg under a SQL workload. But we might as well chuck them across, and we're still getting very good I/O, very good throughput under the different block size and even the higher block size. So, single VM latency. Now, as I say, latency is crucial. How does latency get affected by block size? Well, 4K latency is actually too low for SQL I/O to measure. Obviously, it's not zero. It'd be nice if it was zero, but obviously it's not zero. But SQL I/O's time slicing will round it down to zero if it's less than 0.5 milliseconds. And we can see here that 4K, 32K, and even at 64K block sizes, we're still 0.5, 0.4 milliseconds latency. So this is a real key numbers, this 4 and 64 for SQL. Again, adding the slightly higher block size. Now, performance drops off a reasonable amount when you're looking at very high block sizes, which is fine. But as I say, these aren't the ones that you want to be looking at for a SQL workload. These are just here for comparisons because effectively a lot of people are putting out test results with this half meg block size, and we didn't want to be accused of hiding anything by not inputting the larger block size in. Latency via outstanding I/O. Effectively, what's the queue depth between 1, 8, and 16? Again, latency is the key metric we want to be looking at here. Again, SQL I/O is too low for it to measure. Nice thing to be able to say that your latency is too low for the testing tool, which is meant to measure latency, to even get a result on it. It's actually just rounded down to zero. So amazing result. Random I/O by block size. Again, we're looking at 120,000 IOPS on read and 70,000 IOPS on write. Excellent at different block sizes as well. So, HammerDB. If you don't know HammerDB, that's fine. It's one of the tools that the industry uses just to try and chuck transactions at a database. Now, this is where you're measuring your transactions per minute, and this is the tool for measuring transactions per minute. Now, what we're showing here, because there's a workload called autopilot on HammerDB, and effectively what it's doing is it's increasing the number of workloads and the number of transactions that are demanded of the underlying SQL database, and seeing how we scale. Now, as you can see, we've got a nice straight line, straight-ish line from left to right, which means that we are scaling perfectly. So as you're increasing the amount of workload, we are linearly presenting an increasing amount of transactions per minute back. Now, HammerDB is not a testing tool for storage, it's a testing tool for a SQL database. So you will find limitations in this if you do not have enough CPU, if you do not have enough RAM assigned to your database. So be very careful when you're using HammerDB, because it's effectively testing the entire infrastructure around your database rather than just a storage test. So if you're trying to use HammerDB to compare storage, you must make sure that you effectively over-provision on CPU and memory on your database, and then trying to create the bottleneck to be storage underneath. So another result from HammerDB is the TPC. So this is the creation job. So when you're creating the database, and we can see here that we're almost 4 million transactions per minute. 4 million transactions per minute is a lot. Very pleasing to see that kind of result. And not only is it achieving an extremely high level of performance, we can see how flat that graph is. So we are achieving a consistently high level of performance, and that consistent level of performance is down to being able to provide a consistent low latency storage environment underneath. So, next steps. We're going to send everybody out the white paper. The white paper's got all of these results and explained in more detail as to what we've talked about and the architectures, etc., etc. Effectively, just contact your local representative. We can set you up with a download of the software. You can try it out yourself. All of these testing tools that we've shown in the white paper are all freely available to anyone, so you can go check our work and you can check what's happening in your environment. So I think we've just got a poll, and let me just get that poll up. I'll give everybody a couple of minutes to choose between the very complicated three questions that we've got sitting up in front of you, and it's still changing. So we'll give it another few seconds as people click the buttons. All right, that's pretty much settled down now. All right, perfect. Close the poll now. So I think we've got a few questions that have come in while we've been speaking.
Yeah, for those of you who haven't, for those of you who haven't asked any questions, or if you'd like to, just use the panel on the GoToWebinar utility there, and you can ask a question, and we'll see it, and we'll make sure we get it answered.
So, first question: can you talk about how USX works in a VDI environment? Are the savings the same as SQL? So, it's not particularly a VDI webinar, but I'm happy to touch on it for a few minutes. So it actually works even better for VDI, because the level of deduplication you get in a VDI environment is even greater than the level of deduplication you get in a SQL environment. So effectively freeing us up to provide even more performance. Now, we have a special architecture for non-persistent environments, which uses 100% RAM, and for a persistent environment, then something very close to the architecture that we've been talking about for SQL will do for a persistent VDI environment. We've got loads of resources about VDI on our website, so it's a workload we're very, very familiar with. In fact, yesterday I was with a customer and deploying USX underneath 70,000 user deployment, so that's been a very interesting project to be involved in. Another question: in-memory OLTP is interesting now. What do you see as the impacts? What do you see is the impact to persistent RAM? I don't know what that question means. By persistent RAM, do you mean flash on DIMM? So that's the only kind of persistent, so non-volatile RAM that I can think of. Obviously, it's not RAM; it's flash on DIMM, but maybe that's it. That has got some really interesting consequences because your speed of access and your throughput to RAM is greater than anything else. It beats even PCIe bus. Right now, flash on DIMM is about 2x more expensive per gigabyte than SSD. It's very new. We've done some testing around flash on DIMM. It's great, and I think that maybe in a year's time you'll see more broad-based adoption of that technology, but right now for a general enterprise use case it's probably a bit steep. The question around Hyper-V support plans. So we do have Hyper-V support on the roadmap. It's not a short-term thing, to be honest. Right now we're not seeing the demand from it from our customer base. So for general enterprise workloads, it's vSphere. And for when you're talking to cloud providers, when you're talking to people who are doing a managed service, provide SLA cost, when essentially your cost is the absolute driver, then we're seeing quite a lot of Zen servers sitting underneath those. So yeah, we'll do it. We will absolutely get there. Timings, I can't give you, but it certainly won't be this quarter. As you support vVols, do we support vSphere 6? Yes, absolutely. We have supported vSphere 6 since its release. The architecture we've chosen makes it really easy to do this, right? Because if you are a software-defined storage technology that relies on installing somewhere something into the kernel, or relies on a driver, yeah, then you've got to do a massive amount of regression testing as to when you have new versions and you patch it out to ensure that your solution will keep working. Because we don't do that, because we're taking the virtual appliance route to software-defined storage, that means that all we need to be able to do is support standard connections, so as I say, NFS or iSCSI into us. So essentially, all we have to do to support a new version of a Hyper-V is just update the tools within our virtual appliance OS, and we're good to go. So yes, supported vSphere 6 since release, and also the latest version of Zen server as well. How is USX different to something like Citrix PVS? So another desktop-related question here. So Citrix PVS effectively does a little bit of RAM caching and RAM buffering for writes. It's very situational. It will only work for a non-persistent desktop, and it has issues. In fact, I did a whole webinar on Citrix PVS, so that's able to be downloaded. So maybe as we get some desktop questions as well, we can add the link to the PVS webinar onto the email that we sent out, Michelle. But we will provide I/O acceleration for 100% of the workload. Yeah, whether it's your infrastructure VMs, whether you're doing something interesting like app volumes, underneath your profiles, everything will be accelerated by USX. If you're talking PVS, it only accelerates a very small portion of the I/O stack and is only relevant to that particular non-persistent workload. I think that's most of the questions, which brings us quite nicely to the end of our hour together. So I'd like to say thank you very much, guys, for coming on. Thank you very much for spending your time listening to us. If you've got any questions, reach out to me or Patrick. Twitter is @JimWell. My email address is jim@atlantiscomputing.com. And any further follow-up questions that you haven't put into the webinar, then we'll be very happy to answer.